Hi there, my name is Bruce Rain from Brankus Creations, and in this video I'll be restoring this Macintosh Quadra 840AV. This video is brought to you by channel sponsor PCBWay, but more on that in a moment. The Quadra 840AV was released in July 1993 and was, and still is, the fastest 68K Mac Apple ever released, with a 40 MHz 68040 CPU. The other nifty addition is the AT&T 3210 digital signal processor, which delivered the AV part of the Quadra 840AV's name, and gave it video input and output capabilities. I have a lot of history with this model. The company I work for got one of these back in 1993, and the speed was quite spectacular. And while we didn't do any video production at that company, I remember playing around with the video capture capabilities and being completely dazzled by it. Playing high-resolution video on a computer these days is no big deal, but back then most computers would struggle with any video larger than 320 by 240 pixels. I started seriously collecting vintage Macs about 10 years ago, and the Quadra 840AV has always been right at the top of my wanted list. Unfortunately, the price of vintage Macs has been getting a bit silly, and I've never been able to find one within the realms of my budgetary constraints. Then, out of the blue, I received an email from Jeff. He had been visiting the Quadra 840AV page on my Recap-A-Mac website and read about my desire to own one. He had one that didn't work and was looking into getting it restored, but instead decided to donate it to my Brankus Creations YouTube channel. So when he asked me if I wanted it just for the cost of postage, I said, hell yeah! Well, here is the package. And it's got a slightly worrying sound about it inside, but we'll see what happens. We'll reserve judgment for when I open it up. The Quadra 840AV has very brittle plastics. I wouldn't normally recommend these be shipped under any circumstances, but unfortunately, if I was to go and pick this up myself, that would have been nearly 8,000 kilometre or 5,000 mile road trip, so not really an option. So I've taken the chance with the delivery service, and we'll just see how that has gone. Okay, this looks like it's going to be a little bit challenging. This box is filled with expanding foam. I'm not entirely sure how I'm going to get to the computer. I might need a jackhammer. The foam has really stuck to this cardboard. If this doesn't have a computer in it, I'll be very upset. A really good advertisement for this expanding foam. I think it's Sikaflex. If you know a better way of opening this up, leave a message in the comments. Oi. Oi. Caddy.
CD-ROM caddy. Excellent. Ow. Spiky. Oh, this is a bit of fanciness. Radius. Breakout board. Woo! With mounting bracket. How cool is that? Very good. Good. Oh, pack. I'm going to be very careful here. I don't want to scratch the case at the last minute. Like that. Look at that. It's a computer. I think my bin's going to be full this week. What do you reckon? This front section I'm most interested in because the bezels are very fragile. This back part is made of metal, but all that front is all brittle plastic. Ta-da! Look at that. All 3 bezels still in one piece. That is an absolute victory. So thank you, Jeff. Your packing skills, while perhaps a little overzealous, certainly proved to be very good. Going to be super gentle with this bit. Okay, well, we've got a little bit of broken plastic around here. There's no doubt about the fact that transporting it has come with some issues. And I dare say this startup button is probably just about to go as well. But thankfully, I have the ability to reproduce these in with my 3D printer. Okay, so some of the broken plastic is from inside here, and it looks to me like in transport this NuBus card has fallen out, and that's what the rattling was. It's meant to be held in, but the plastic that holds this bit in has busted here. So I'd say that's rattled all the way out. But having said that, it does look intact. I don't see any missing components. I don't think anything's been knocked off, so I've got to say that's pretty good. Now that there is the Radius VideoVision card. That's what will allow us to do some pretty amazing stuff. Well, amazing for the time. Let's just say that. And then we also have here, yeah, this is falling apart. This is going to need a little bit of arrow done, I think. We have this card here. I can just get it out. I might put this on his side and let all the plastic fall out. There we go. And this is the FWB SCSI JackHammer. We'll be having a look at this a little bit further. So this is where we can start connecting fast SCSI hard drives, getting much higher speed from the SCSI bus. So, but it is in one piece. I can see on the board some pretty ugly corrosion, so this is going to be a resto. It is also a green board. This board came in 2 flavors. It came with a green board or a black board. The green one is a lot easier to work with because the traces are just quite simply, it's easier to see. The black ones, they're incredibly difficult to see. So, what can we say? At this stage, we have ended up with quite a bit of broken plastic, but thankfully it all appears to be inside areas that aren't actually seen. The stuff that is important is having this front faceplate, or these bezels, all in one piece, and of course this back section and this one is all in one piece as well. Just hanging on, just hanging on. So that went quite well.
You might already know about PCBWay's excellent PCB prototyping and production capabilities, but did you know that they also offer PCB assembly? In fact, there's not a lot they don't do at PCBWay. They are a real one-stop shop providing flexible PCBs, SMT stencils, CNC machining, 3D printing, sheet metal fabrication, laser cutting and injection molding. They even have this really cool online Gerber viewer so that you can upload your Gerbers and see what your PCB project will look like when complete. And be sure to check out the shared projects page and see the amazing projects people are coming up with. I do hope you'll give PCBWay a try.
While cleaning the packing material from the floor, I found this, a 22 microfarad tantalum capacitor that must have got knocked off during transit. Thankfully, after a quick inspection, I found a gap on the Radius VideoVision board at position C30. So I just need to solder that back onto there. Despite all the things that I love about the Quadra 840AV, there is one thing I find infuriating, and that is the internal design. If I want to upgrade the RAM on this computer, I have to take this logic board out. And that involves removing the NuBus cards, removing all of these connectors from the top, removing these buttons from the side, undoing a screw, and then lifting the board out. And that is an absolute pain. Mind you, I do remember getting pretty quick at that back in the day, but I wasn't dealing with brittle plastics back then. Okay, out comes the floppy connector. That is the CD-ROM audio connector. That is the speaker connector. Here's the power connector. Come on. Come on. Power connector. Then the SCSI ribbon cable. That's all the connectors done. And I now need to try and get this switch out without breaking it. And it just wants to break. But I managed to get it out. So there's the little power button. We've got the connector here for the LED light on the front. And this is the screw that we need to remove. Okay. So we should just slide this forward, and then it only needs to come forward a little bit until this is in the little notch, and then lift this little plastic tab up, and it didn't break, and I'm happy. And then I've got the connectors for the video in and video out, and there is the logic board. And so we've got our 68040 CPU there. We've got a battery, which I am now going to banish from the board because I suspect it is the original one. And we have got some video RAM here and some normal RAM here. And it looks like it's fairly well loaded up. I'll be interested to see how much RAM it has when we fire it up. And over here, we've got some of that nasty corrosion from leaky capacitors. And we've got the same around here, got the same around here. So this one will definitely benefit from a recap and a good clean. One of the first things we have to do with this Quadra 840AV logic board is recap it. Replace the old leaky electrolyte capacitors with new ones. I'm actually opting to replace them with tantalums. Now, it's not just the logic board we have to worry about with the Quadra 840AV. We've also got the power supply, which will probably need recapping. The caddy load CD-ROM drive will definitely need recapping. Even the floppy drive has a couple of surface mount electrolytic capacitors which are going to have to be replaced. So it is quite the restoration job to do this computer. And before we get started on the recapping, I've got my VideoVision card here with my little capacitor that has fallen off. So I'm going to stick that on first. Okay, there is the spot. I am first of all going to remove any of the old solder from these pads. make sure those pads are all nice and clean. Then I shall drop the component on here, like that. Get a little bit of flux. Going to get a little bit of solder onto the tip of my iron here, like that. Hold the component in place. And solder. Okay, as good as new. No one would ever know it was missing. So the 840AV has 15 surface mount electrolytic capacitors, which we're going to have to replace. There are 13 47 microfarad 16 volt and 2 10 microfarad 16 volt. Now, I have a recapping guide for the Quadra 840AV on my website, recapamac.com.au. There is a link to it in the description. Now, the first thing we have to do is get the old capacitors off. And there are a couple of different ways that can be done. I personally use a hot air station. Some people opt for the squeeze and twist method with a pair of pliers. I don't do that. I never will do that. I think it's too risky. There's too much potential for damaging the board. So I'm going to be taking these off with my trusty hot air station. Any of the equipment that I use, you'll find links in the description for either what I use or some budget alternatives. If you have a look here, you can see I've actually got some corrosion occurring near this capacitor. That's occurring because of the electrolyte that has leaked out of this capacitor. So we need to get him off the board as quick as possible. And it smells. I've got some little blobs of component adhesive here. To get those off, just hit them with a bit of heat, and then you can scrape them off quite easily. Just got a little bit of metal in here to shield the plastic from the hot air. Okay, I am pretty sure that's all of them, so all I have to do now is get all of these pads cleaned up, ready to stick a new component on them. So I'm just going to get some flux applied liberally to the area. Going to put some fresh solder on these pads. And just give them a gentle rub. Just want to make sure that the whole pad is accepting solder and there aren't any little crusty bits on the ends. Then clean that solder off with some solder wick, and those pads are looking like brand new. So it's got some gunk. You can see up the top here there's this black gunk on the end of the pad. I need to make sure that's all gone. So I'm just going to keep gently rubbing. If I can't get it off with a bit of gentle rubbing and heat, the next is to try and get it off by a bit of gentle rubbing with some solder wick. And if I end up with some really stubborn gunk on there, I resort to a scalpel blade to scrape it off. Okay, that is all of the pads cleaned up, all ready for new components to go on. So I'm going to grab my replacement tantalum capacitors and I will begin. So I am going to need two 10 microfarad 16 capacitors and 13 47/16. 1, 2, 4, 7. An important thing to remember if you're using tantalum capacitors in place of electrolytics, electrolytic capacitors have the stripe on the negative side, tantalum capacitors have the stripe on the positive side. So make sure you get your polarity right. I'm going to start with my two small 10 microfarad 16 volt. And to get some flux onto the pads, grab my replacement capacitor. That's the positive there, and let's solder it on. Get some solder onto the tip of the iron, and the flux will help it just transfer onto the pad and the component, just like that. One down, 14 to go. And the rest are all 47 microfarad 16 volt. Snug little fit in there. I'm going to grab a slightly different tip that I can squeeze into that gap a bit better. Okay, that is it. 15 capacitors replaced. I always think it's a good idea to check your work thoroughly. So if you've recapped, go back, check again, make sure that you've got the right caps in the right place. Check to see that you've got the polarity right. Check to make sure you've soldered down both sides of each capacitor. Once you're absolutely happy with the work that you've done, then we can move on to the next step. And for this, the next step is cleaning. This is very, very dirty. We've got lots of corrosion down here. We've got dust, we've got gunk. And so I need to chuck this into an ultrasonic cleaner to get it cleaned up. Now this is quite a big board, so it's going to need a big ultrasonic cleaner. I use a Vevor 30 litre ultrasonic cleaner. I did a review on this cleaner. There's a link up here if you would like to check out that review. There's also a link in the description for where you can buy one with a discount code. If you're going to be cleaning a board of this size or bigger, then that's the ultrasonic cleaner you're going to need. Because this board is particularly dirty, I'm probably going to give it around about 15 minutes per side in the ultrasonic cleaner.
Here is the Quadra 840 AV logic board before and after recapping and cleaning. The white stuff on the CPU is thermal compound. I accidentally put a bit too much on. After recapping, I put the Quadra 840 AV back together for a test. And nothing. Dead power supply. I was going to need to fix that too. I took it down to the workshop and started the repair. It was a huge pain to dismantle, and I soon discovered that it used capacitor sizes I didn't have available. And there was a cooked resistor, but it was so discoloured I couldn't make out the original resistance rating from the coloured bands, so I couldn't even figure out what to replace it with. One thing I didn't mention earlier on was that I have a spare power supply for the 840 AV. It's made by a different manufacturer, but is 100% compatible. At this point, my impatient desire to get the computer up and running got the better of me, so I abandoned the power supply repair, for now, and decided to use my spare. For my first test, the power light came on and the speaker made a popping sound, but no chime and no video, so I headed back to the workshop for a close inspection of the board. It turns out that during the recapping, I got a little overzealous with the hot air while removing capacitor C75, which is right next to the digital signal processor chip. I had inadvertently heated up the pins of the DSP, which had resulted in some solder squeezing out and bridging these two pins here, and that was why the Mac wouldn't boot. After removing the excess solder, I gave it another try. And there we have it, a nice loud chime and the flashing question mark, showing that it's ready for a system. There's no hard drive in here, so I'm going to use my trusty BlueSCSI V2 SCSI emulator. This is the external version, so I can plug it straight into the external SCSI port and boot. A big thank you to the BlueSCSI guys for sending this to me for testing. And here we are, booting into System 7.5. The Quadra 840AV was originally released with System 7.1, but runs quite happily on 7.5. You can also run the later System 8.1 on the Quadra, but the performance is definitely better with 7.5. So let's run through a few tests. I usually start with a snooper test to make sure the hardware is all working well. I have two 32MB SIMs, a 16MB and an 8MB, giving me a total of 88MB of RAM. I do plan to max this out to the full 128MB in the future, but 88MB is fine for now. I'll also do a speedometer test to check its performance. I've plugged it into Ethernet and am using the iCab software to get onto the internet. I'm using FrogFind, the excellent tool created by my good friend Sean from the Action Retro YouTube channel. Be sure to check out his shenanigans. Let's check out the Quadra 840AV page from my Recap-A-Mac website. Once you strip away all the graphics and JavaScripts, we're really not left with much. Here's a really old HTML1 page I created in the 90s. It's slow, but it works. The Quadra 840AV didn't come with a hard drive, but even if it did, I probably wouldn't use it. The old mechanical hard drives are getting more and more unreliable as they get older, and I'm much better off using a modern SCSI emulator such as a BlueSCSI or a ZuluSCSI. And what I'm going to use is this one here. It's a ZuluSCSI Compact Homebrew, and it's basically the ZuluSCSI RP2040 model on a compact board like this, and all of the surface mount components are soldered on, but we have a little baggie here with the through hole components that we need to solder on. So it's like a little kit. And so I'm going to put this together now. I think it should be fairly straightforward. We've got our little Berg connector here, which we don't really need. This is only if you need to actually supply power to this, but you know, this gets power from the termination power on the ribbon cable. So I'm working off an image of one of these that has been assembled, and as far as I can tell, we've got our Berg connector here, we've got our 50-pin connector here, we have our smaller capacitor that goes there, and we have our bigger capacitor going here. And then we have a little jumper there for the remote LED light, which I do plan to use. And then I've got two little jumpers here with a jumper shunt already on it. I don't know what the second one is for, but the first one is certainly going to go there for SCSI termination. So that's what I will be putting together. So let's start soldering. Okay, well that was definitely a very quick and easy assembly process, and that's pretty much ready to go. Now, one of the great things about this compact is that it has these mounting holes here, which are actually in the same position as the larger models of ZuluSCSI, and in actual fact going all the way back to the SCSI to SD. They've been using the same footprint for many years now, and so I have this mounting bracket here which I've 3D printed. There'll be links in the description as to where you can get the STL for this if you want to 3D print that yourself. As I say, this is designed for the larger ZuluSCSI, but I will probably rework this, you know, for this compact one, but in the meantime this one will still work. I can just screw onto those two holes there, and that will work perfectly well on that mounting bracket. Now, I got hold of this a while ago. A big thank you to the guys at Rabbit Hole Computing, there, for sending this to me to try out. I really appreciate it. I'm going to run some speed tests on this, but before I do that, I'm going to update this onto to make sure it's got the latest firmware, and then I'll be putting it in the Quadra 840 AV, and we'll see how well it runs. I'll be testing it on the internal SCSI bus, and then I'll also test it on the SCSI JackHammer card to see if we get any speed improvements. The ZuluSCSI is now installed on the drive sled and installed in the top drive bay of the Quadra. I've also set up a drive activity light. Older Macs like the SE, SE30, 2CX and 2CI had a drive activity light at the front of the computer, but Apple stopped doing this. I've always liked to be able to see if the drive is being accessed, so I've come up with this makeshift solution. I've soldered wires to this blue surface mount LED light and have placed it directly behind the Quadra's green power light. So now when there is drive activity, the power light flickers blue. Totally unnecessary, but I like sparkly things. This is the SCSI JackHammer card. It has one internal 50-pin connector for narrow SCSI and a 60-pin internal and external connector for the faster wide SCSI. I can only test the ZuluSCSI with the narrow connection because it has a 50-pin connector, but it'll still be interesting to see if there's a difference between the Quadra's internal SCSI bus and the JackHammer. I do have a 68-pin wide mechanical hard drive, and we'll check the results from that as well. So here are the test results. On the top left we have the ZuluSCSI internal, and that's running off the Quadra 840 AV internal SCSI bus. In the bottom right hand corner is the same ZuluSCSI drive but running off the JackHammer. Now, I'm not sure why, but the seek is actually a little bit slower. You can see those numbers are a bit bigger there. Sequential 1.55 versus 2.15. For some reason on the JackHammer, the seek is a little bit slower. But if you have a look at that max read and max write, you can see a really big difference, quite a significant difference in throughput when the ZuluSCSI is connected to the JackHammer. If we look at the top right, you'll see the BlueSCSI external, very similar seek times to the ZuluSCSI, but a little bit quicker on the throughput, certainly for the read, very, very close on the write speed. So just a little bit quicker on the BlueSCSI than the ZuluSCSI there. And then in the bottom left is the 9GB IBM mechanical hard drive. Now this is a wide SCSI drive, which means it has that 68-pin connector. As you can see, the seek speed is quite a lot slower, as you would expect because it's a mechanical drive. But have a look at the speed of the throughput. We're getting up nearly to 11 megabytes a second. Maximum write just under 10 megabytes a second. So that is actually a really impressive result from that old mechanical hard drive. So for video capture, I actually think this mechanical drive will be the best one to use because it's sustained write speed that is of real importance when capturing high resolution video. So for that reason, I'll be keeping this IBM drive installed in the second drive bay for my video experiments. To complete the restoration on this Quadra, there are two more jobs that need to be done: recapping the CD-ROM drive and the floppy drive. I decided to do these during a live stream on the 22nd of July, and if you want to watch the whole thing, you can do so with this link here. Alternatively, here are the highlights. These are friggin' through hole. Son of a gun. Hello chickens. Oh, and pigeons. Piss off, pigeons. I'm going to just clean the heads of this while I've got it open. How many other scopes are there? Stethoscope? What else? But this one I just call scope because it's the only one here.
Smash that like button.
Okay, so let's put this guy back together. CD-ROM drives, these really need recapping in a big way. Things like that shouldn't be green. Just putting it out there. Wow, there is actual liquid here, actual in liquid form liquid. Ah! It just blew up. Careful. Oh no. Oh no. Just making sure these pads have got a nice fresh coat of solder on them. We're going to need to clean it up a bit because it's a mess. It's lost a leg! It's lost a friggin' leg! Look! Lost the leg! Consarn it! Hey, look at that. We got ourselves some copper. Oh, that chicken's lucky we're eating out tonight. That's all I can say. It's not pretty. It's okay. No one's going to see this. It'll be sealed away. So the next thing this is going to do is get a good old ultrasonic clean, so we get this as clean as possible. And then I will put it back together and test it out, and hopefully it will work. Not particularly surprisingly, the CD-ROM didn't work after recapping. I plan to spend a bit more time on it, but in the meantime I have this spare drive which I'm using instead. The floppy drive works perfectly. So here is the fully restored Quadra 840AV and working beautifully. Every time I work on it, a bit more plastic falls off, but while it's screwed together with the case on, it's pretty solid. At the beginning of the video I mentioned this Radius VideoVision card. My good friend Steve from the Mac84 YouTube channel did a video on this card which you can check out here. He had all sorts of problems while trying to work with it, which makes for some entertaining viewing as the ongoing faults gradually crush his enthusiasm throughout the video. I have been a bit luckier though, and my tests have gone quite well. This video was captured using my Panasonic AG HMC41E video camera. Even though this is an HD digital video camera, it still has the ability to output an analog composite video signal, which I can plug into the VideoVision breakout board. This allows me to capture the output at 720 by 576 pixels at around 5 megabytes a second. From there, I can bring this video footage into Adobe Premiere version 3 and cut it together. I can even use some of these amazing edit transitions that came with it. The process is slow, really slow. Previewing the output takes forever and exporting the finished video literally takes hours. But it was a lot of fun and allowed me to experience the joys of digital video editing from the early 90s. Once again, thanks to Jeff for his generous donation to the channel. I'm absolutely thrilled to have a working Quadra 840AV in my collection now. If you enjoyed this video, please consider liking it and subscribing to my channel. Thanks for watching.
Catherine, my love, I have to leave quickly. Something terrible has happened. It's hard for me to believe.